Imagine waking up to an unprecedented solar storm. A superflare erupts from our sun, threatening life on Earth. This isn't just science fiction, it's a real possibility with catastrophic consequences. Our sun is a powerful star, capable of releasing bursts of energy far beyond its usual output. These rare events, called superflares, could unleash a fury upon Earth, impacting every aspect of modern life. Superflares can release energy equivalent to billions of atomic bombs. If such an event were to hit Earth tomorrow, our technology-dependent world would face unprecedented challenges. From power grids to communication satellites, our infrastructure relies heavily on electricity. A direct hit by a solar superflare could cause widespread blackouts and disrupt global communications. In the aftermath of a superflare, recovery efforts would face immense hurdles. Critical systems like water treatment plants and hospitals could fail, leaving populations vulnerable. Understanding the threat posed by solar superflares is crucial for preparing and mitigating potential disasters. Scientists are studying past events to predict and prepare for future ones. While the probability of a superflare hitting Earth is low, the impact would be devastating. By understanding and monitoring solar activity, we can develop strategies to protect our planet. Modern society relies on a stable environment to function. Solar superflares pose a significant threat, but with research and preparedness, humanity can safeguard against these cosmic threats. As we continue to explore space and understand our solar system, we uncover new risks and opportunities. The threat of a solar superflare highlights the importance of space weather research. A solar superflare is an extreme eruption from the sun, capable of releasing energy equivalent to billions of atomic bombs. This intense burst of radiation and plasma could disrupt Earth's magnetic field, affecting technology and life. Historically, the Carrington event in 1859 was a powerful solar storm that caused widespread telegraph disruptions and spectacular auroras. A similar event today could paralyze global communications and power grids. Modern satellites and GPS systems are particularly vulnerable to solar superflares. Disruptions could lead to navigation failures and communication breakdowns, impacting everything from smartphones to aircraft. A solar superflare would induce geomagnetic storms, creating surges in electrical currents that could overload transformers and cause widespread blackouts, potentially lasting months to years. While solar superflares are rare, understanding their potential impact is crucial for developing protective measures. Scientists monitor solar activity continuously to predict and prepare for such events. Protecting against solar superflares involves shielding electronic infrastructure and developing backup systems. Countries like the United States have plans to mitigate risks associated with solar storms. Despite the risks, solar superflares offer a unique opportunity to study the sun's behavior and improve our understanding of space weather, which can help protect Earth's technological infrastructure. Solar superflares can also affect Earth's climate, though the exact impacts are still under investigation. Changes in solar radiation could influence weather patterns and atmospheric conditions. Understanding the frequency of solar superflares is challenging due to limited historical records. However, studies suggest they occur less frequently than regular solar flares, but with greater intensity. Earth's magnetic field provides some protection against solar superflares, deflecting charged particles away from the planet. However, this shield isn't foolproof and can be overwhelmed by extremely powerful events. Space weather forecasting aims to predict solar superflares and other solar events. Advanced models and observations help provide early warnings, giving time to prepare and mitigate potential impacts. In the event of a solar superflare, emergency protocols would activate. These include shutting down vulnerable systems and implementing backup procedures to maintain critical services during the crisis. Research into solar superflares has led to advancements in solar physics and astrophysics. Understanding these phenomena helps us better comprehend the dynamics of our star and its effects on Earth. Protective measures against solar superflares extend beyond Earth. Space missions must account for the risk of solar storms when planning voyages to Mars and other planets. Solar superflares highlight the interconnectedness of Earth and the Sun. Our planet's well-being depends on understanding and mitigating the effects of these powerful solar events. While the threat of a solar superflare is real, the likelihood of one occurring tomorrow is low. Continuous monitoring and research help ensure that we're prepared for any solar event. Preparation for solar superflares involves international cooperation among governments and scientists. Sharing data and coordinating responses are key to minimizing damage from solar storms. Technological innovations, such as advanced power grid designs and hardened satellite components, aim to withstand the impacts of solar superflares, ensuring continued functionality even during extreme space weather events. Educating the public about the risks of solar superflares is essential for community resilience. Awareness campaigns can help individuals and communities prepare and respond effectively to solar storms. Solar superflares remind us of the delicate balance between Earth and its parent star. By studying these events, we gain insights into the workings of the Sun and how it influences life on our planet. As we continue to advance technologically, the importance of protecting against solar superflares grows. Ensuring our systems are resilient against solar storms is crucial for maintaining modern society. Future missions to explore the Sun will provide valuable data on solar superflares. Understanding their origins and behaviors will help us develop better predictive models and protective technologies. Collaborative efforts between space agencies and researchers worldwide focus on enhancing our knowledge of solar superflares. Through shared expertise and resources, we strive to safeguard our planet from these cosmic threats. By investing in research and infrastructure improvements, humanity can reduce the risks posed by solar superflares. Preparing for these rare but impactful events ensures our resilience and continuity in the face of solar activity. A superflare would release enormous amounts of energy, potentially 10 times stronger than typical solar flares. This intense burst could disrupt satellites, causing widespread communication failures and blackouts. To protect against superflares, scientists recommend enhancing the resilience of electrical grids. Shielding transformers and improving backup systems are crucial steps to safeguard our infrastructure. Monitoring solar activity is vital for early detection of potential superflares. Space observatories continuously track the Sun, providing data critical for predicting and preparing for such events. In the event of a superflare, emergency protocols would activate. Governments and utilities would coordinate to minimize damage, prioritizing essential services and rapid recovery efforts. Understanding the risks of solar superflares helps us prepare and mitigate their impact. By investing in advanced warning systems and infrastructure improvements, humanity can safeguard against these celestial threats. Scientists continue to study the Sun's behavior to predict and prevent potential disasters. Their research provides crucial insights into the nature of solar flares and how to protect our planet. Every day, our solar system presents new challenges and opportunities. The Sun, a constant presence, also harbors hidden dangers that remind us of our vulnerability. From ancient times to the present day, humanity has looked to the heavens for guidance and inspiration. Today, understanding cosmic threats like solar superflares ensures our future survival. Investing in space weather research is essential for protecting global communication networks, power grids, and satellite systems from the devastating effects of solar superflares. The potential threat of a solar superflare should not paralyze us but inspire action. We must harness our knowledge and technology to secure a safer future. By staying vigilant and prepared, we can turn the threat of solar superflares into an opportunity to innovate and strengthen our resilience against all natural hazards. While solar superflares represent a significant risk, our collective efforts in science, technology, and international cooperation offer hope and protection for our vulnerable world. In facing the challenge of solar superflares, humanity stands united by a common goal: to preserve our way of life and ensure a sustainable future for generations to come. We must embrace the lessons learned from studying celestial events and apply them to safeguard our planet. Together, we can overcome the threat posed by solar superflares. As we look up at the sun, let it remind us of both its power and the resilience of humankind. With continued research and preparation, we can ensure a brighter, safer tomorrow. Deu Adorada.